It is the final phase of the Soyuz automated sequence. It lasts 5 minutes and 20 seconds.
For tonight's launch, we use Galileo, the CSG station of CSG in French Guiana, 2 Canadian stations, Saint-Hubert and Saskatoon, the Indian station of Lucknow, and finally, a station located on Mauritius Island in the Indian Ocean. These stations allow us to follow the launcher during the main phases of the flight, and because of the duration of the mission tonight, each of them will be used at least 2 times. The data collected by these stations are sent in real time to the CDLS, the Soyuz Control Center in French Guiana, and to the Frigate Flight Monitoring Center in Moscow. And the parameters that are the most representative of the functioning of the launcher are monitored by a set of technical experts from Arianespace and from its Russian partners. These data concern the propulsion of the launcher, its trajectory and the flight control. They are compared to the forecast throughout the flight, and a continuous synthesis of the launcher behavior is done for the high management in Jupiter and for the launch teams in the CDLS. This is what we call the CVI, or the Instant Visual Control. This real-time monitoring is really important, as it allows to check that the flight is nominal and to confirm our customers that their satellites were separated as expected.
And this is mission control, and here we see the launch pad. You see this big gray metal mast is called Upper Composite Umbilical Mast, or KZM. You're going to see it pull it away just before the launch, 35 seconds before the launch. Umbilical means that inside there are the umbilical lines that take info from the satellites to the team on the ground. When it is disconnected, it means that our satellite will not be powered by the ground any longer and will start to survive on its own, will be powered on its own batteries. And Sentinel-1B will stay on its own batteries as long as, after separation, has not deployed its wings, has not opened its solar array, reaching what we call a power positive state, meaning more power comes in that is needed to survive. A word on the ignition sequence of Soyuz. Soyuz, there is a system for checking the health of the engines before it leaves the pad. It ignites all 5 engines 17 seconds before liftoff. There are 4 on the 4 boosters and 1 on the core stage. They are throttled them up gradually, gently, to check that engines are all working fine. Remember that Soyuz also carries people, not tonight. So, when they reach full thrust, then you will see the vehicle leaving the pad. Moments of very high concentration for all of the teams that have been working so hard.
À tous de DDO. Attention pour moins 1 minute. Top. H0, moins 1 minute.
And we are 1 minute to launch. We are live at the Guyana Space Center, and we're launching Sentinel-1B, built by Thales Alenia Space of Italy for the European Space Agency and the European Commission, part of the Copernicus system. We are launching Microscope, a scientific satellite of the French Space Agency, CNES. And we launched 3 small satellites built by students under the ESA program, Freya Satellite. Our best wishes to all of the teams.
Attention pour le début de la séquence d'allumage du lanceur. Top, H0-20 secondes. largage du mauvais KM, allumage du triétage. À tous les déos, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Décollage, Liftoff VS14.
We are off, hauling ourselves against the gravity of the Earth. 336 tons, the equivalent of 22 buses. And we're heading north, out over the Atlantic, and then over North Canada. So at the moment, Soyuz is burning its 5 engines, 1 on the core stage, 4 on the boosters. The boosters are doing most of the work. Their job is to get us away from Earth and defeat gravity, which makes us stick to our planet. They have a very short-lived job.
Le vol est nominal, les paramètres sont normaux.
All parameters are nominal. They have a short life. They're going to be separated, and you will see them drop on the ground just before 2 minutes in the flight, so very soon. They are powered by liquid oxygen and kerosene. If we get lucky, we should be able to see the separation of the boosters, which is a magnificent sight.
La propulsion du premier et deuxième étage est nominale.
All is nominal on board. Watch for 158. Separation of the boosters. You can't, but I can see the roar of the engine from where I'm staying. So the burn of their propellant, so we don't need them anymore. They fall back to Earth, and we are shedding weight, which is the whole trick of a launch. The lighter we are, the faster we go. So we are start to burn the second stage, or the block A. This will burn for just under 5 minutes. If you look at the trajectory, as we call it, this curve on the right upper corner of your screen, this shows the theoretical path that we are following tonight and the actual path, this white dot. So as you see, everything is nominal. We are coming now to the altitude. Look on the bottom left, where we can get rid of the fairing. The fairing has these 2 shells that protect our precious payload. They protect it from the acoustic vibration at liftoff, the very loud noise, the roar of the engine, and from the friction, the resistance, the pressure, then the air layer are here we go, are exercising on the launcher during the ascent. Here they go, we have jettisoned the fairing. We don't need it anymore. We are now outside the atmosphere. And if someone asks you how much time it takes to go to 700 kilometers, answer, 23 minutes. This is what it will take us today. So probably less than what it takes every morning to go to work. So we have seen our satellites for the first time, and this is always an emotional moment, even when it is only computer-generated images. Here we see the teams. I'll tell you, they've really worked hard in all these days, and they kept the concentration, and today is the day.
La propulsion du deuxième étage est normale.
So we're coming to the point where the second stage will be shut down, will be falling away, and we will start igniting the third stage. Here we go. We are now burning the third stage. So we launched Sentinel-1A 2 years ago, and we're launching its twin tonight.
Séparation du deuxième étage. Séparation de la butte. Interétage.
On the 14th of April 2014, the European Space Agency launched the first of its new line of Sentinel Earth observation satellites, Sentinel-1A. It was sent into orbit on top of a Soyuz rocket from the European spaceport in Kourou, French Guiana. Now, almost 2 years on, it's time for Sentinel-1B, its identical twin brother.
Sentinel-1B is the first of the second satellites, so to speak. We have already launched the so-called A satellite, and this will help us to have the double amount of data, or only half of the time to wait. In practice, we can get from any place on Earth, we can get within 6 days an image with the A and the B units together.
To achieve this, both satellites will be flying in the same polar orbit, 180 degrees apart, working together as a constellation. They carry a powerful synthetic aperture radar, or SAR instrument. This radar allows the satellite to provide images of the Earth's surface under all weather conditions, day and night. The unprecedented speed and resolution of the Sentinel satellites is providing an unparalleled amount of data, making it a true success for the scientific community worldwide.
It has gone far beyond our expectations. Besides some 80 services which are operational and also supported by the European Commission, there are now national services emerging, and we have 27,000 self-registered users who have downloaded already 500,000 of images, and I tell you, you don't download a radar image if you don't really need it.
The radar images provided by the Sentinel-1 satellites will allow scientists to detect small changes in volcanic activity, routinely map sea ice to help ships navigate through our increasingly crowded polar seas, and allow a better management of shipping routes worldwide. These are but a few examples of the services provided. Sentinel-1A and 1B are not the first satellites monitoring our planet, but they will be the first ones to do this continuously as an operational tool within the Copernicus program.
This is a real game changer, if I can say that. We want to do now, or we do now, what we have done 35 years ago with the meteorological system, operational satellites. That means we will ensure for many, many decades operational services, and this ensures, on the other hand, the users that they invest in new applications, be it governmental or be it private.
The Sentinel-1 satellite mission is an important part of the European Union Copernicus program, for which ESA and the EU are planning to deploy 6 families of Earth observation satellites. Each of these families will address specific needs, and all will provide crucial information to better understand our planet. The information can help mankind to plan a sustainable future for itself and the planet we all share.
And you have heard Professor Liebig, the Director for Earth Observation Program at ESA, explaining which wealth of data Sentinel-1A is already delivering in its 2 years of operation. And with the arrival of its twin that we're launching tonight, and with increased exploitation of Sentinel-1A, by the end of the year we will deliver to the user 3 times the amount of data we are delivering today. And you've seen, this is the moment of the third stage engine shut down. We have separated it, and now it's Fregat who takes us to orbit. Its job is to deliver our satellite to their drop-off point in space. Tonight he has to deliver 3 separate missions, and it's going to take about 1 hour to do that, so quite a journey. Let's explain what will happen. First, we're going to climb to about 700 kilometers altitude, which is the drop-off
Acquisition de la
point
télémesure
of
lanceur par la
Sentinel-1B.
station de Saint-Hubert au Canada.
Then we will go down, and we will go down by more than 200 kilometers to deliver, fly a satellite. We will then climb up again to just above the 700 kilometers when we left Sentinel-1B to separate Microscope. You've seen now that the first burn of frigate has started. This last just over 10 minutes, and the satellite is now being acquired, sorry, not only the satellite, the upper composite frigate has just been acquired by the station of Saint-Hubert. Our flight path tonight takes us north, so we are over northern Canada, and it is there, not yet, where we will separate Sentinel-1B. Why are we flying north? Are we flying north because we are launching an Earth observation satellite, Sentinel-1B. An Earth observation satellite have to be able to cover the complete globe, and they do that by being placed on an orbit which goes over the poles and exploiting the rotation of the Earth beneath them. They cover the whole globe. It's like peeling an orange slice by slice. So Sentinel-1B was built by a consortium of European companies led by our friends at Arianespace in Italy. They are great experts in Earth observation and in radar system. So they're very proud of their contribution to understanding our planet.